And good morning, everyone. I'd like to welcome you to Makersite's latest in the Masterclass series, How to Evolve Beyond Spend-Based Scope 3 Reporting. Thank you so much for joining us. Before we get started, I'd like to give my co-presenter, Fabian Hassel, an opportunity to introduce himself.
Hello everyone, Fabian Hassel. I'm today basically the co-host. I'm going to do the second half of the session for Makersite. I'm the VP Service, also founding member of the company. Sustainability is practically my field. I'm doing that since the last 18 years, before really beginning with Makersite some year ago. Been working with Gavi databases for a while, have implemented EHS software and worked with EHS software in the field. But followed my true passion, which is really about how to make better products, how to report on products, and look at a more holistic picture on company performances. And today I was really asked to give you an insight a little bit how to overcome a certain data challenge in scope 3 in particular, and maybe give you also an insight into our existing or in some of our customer cases where you see which problems we have solved. Thank you. Pablo.
Thank you, Fabian. And I'm Pablo Päster. I'm a father of 4 based in Northern California. I'm the sustainability engineer on the US team of Makersite. I've spent the last 20 plus years working with enterprise greenhouse gas management with over 100 clients such as Apple, HP, Microsoft, Wells Fargo, and so on. Primarily, again, on enterprise greenhouse gas management, which includes all 3 scopes. I also have a history in product carbon footprint going back many years as well. So who is Makersite? We are a software as a service company based in Germany with teams across Europe and the US. We were founded by industry veterans with a background primarily in LCA and product carbon footprint. We have over 100 employees as of recently, and we have the pleasure of supporting over 60 enterprise customers. Our mission is to empower companies to make better, faster decisions and create compliant and sustainable products and supply chains through data-driven analysis. We're much more than a tool, though. We're also a partner. Whether you're just starting your journey or pushing for full transparency, we guide you through every step of the way, turning challenges into opportunities for growth. So as we get started with our presentation and go through the slides, think about where you are today and where you'd like to be tomorrow. So first, I'll be taking us through why estimating Scope 3 emissions is hard. And then we'll get into spend-based versus activity-based Scope 3 modeling. And then we'll hand it over to Fabian to talk about effective data aggregation techniques, decoding your data, seamless integrations, and as promised, some real-life success stories. And then finally, we'll wrap it up with some Q&A to get to hear all of your great questions. So to start, I do want to start with some basics. I know we're all sustainability professionals here, and I'm sure everyone knows Scope 1, 2, and 3, but I do want to frame a couple important points, so I want us to get on the same page. So the GHG protocol was developed back in 2001, and they really defined this concept of scopes. And so Scope 1 refers to direct emissions from an entity's owned or leased assets. So for example, if you burn some diesel in a generator, the emissions of that are yours. They're directly emitted from your assets. Scope 2 refers to energy that is produced directly on your behalf, but outside of your organization's boundaries. And so that includes heat, steam, chilled water, and certainly electricity. So when you flip a light switch, you do control that flow of electrons that ultimately comes from a power plant somewhere. And so those emissions are considered part of your Scope 2. Both of these are tied to a limited specific reporting period, which is typically a fiscal or calendar year. Now, for most of my career, clients have focused on scope 1 and 2, and if they have ventured into scope 3, it's primarily been business travel. Now, this changed a few years ago when companies started expanding to the other categories of scope 3. And now it's become essentially the norm that you do some degree of accounting in the relevant categories of scope 3. But it's infamously challenging. Scope 3 has been described as the catch-all for everything that goes beyond scope 1 and 2, and it comes with some unique complexities. So while scope 1 and 2 attribute emissions neatly to an entity and to a period of time, scope 3 often does include double counting, and that's actually by design. Additionally, these emissions don't necessarily always occur within the reporting year in question. So let's take a closer look at what makes scope 3 so complex. It's often said that scope 3 accounts for the most of a company's greenhouse gas emissions. Now, this is true for many organizations in terms of absolute emissions that are estimated or calculated, but there's an important distinction to make. Scope 1, 2, and 3 emissions represent what a company is taking responsibility for. That doesn't necessarily always align with what they can influence. Differentiating between responsibility and influence is critical as we evaluate scope 3 emissions. Scope 3 is divided into two main groups. Categories 1 through 8, shown here in red, cover upstream emissions. So that's everything that happens upstream of your organization before getting to you in the value chain of creating products or services. Categories 9 through 15, shown here in green, represent downstream impacts. So that's primarily the impacts of your products and your activities downstream from your organization. And these all have very unique challenges. For example, looking here at category 3, fuel and energy related activities. Now, this is the energy used in refining, in mining, and so on for the energy that you ultimately use. But it can be extremely difficult to influence because you have so little visibility into where the oil for your gasoline comes from, or other resources are extracted to provide the energy to you. Others, like air travel, may happen regardless of your company's efforts. So if one of your employees takes one less flight, that airplane is still going to take off and fly. So those emissions are going to happen anyway. So this all adds complexity to the various categories of scope 3. Additionally, some emissions categories, such as 10, 11, and 12, which are processing of sold products, use of sold products, and especially end-of-life treatment, might not occur for many years after you have produced the product and it's left your factory gate. Now, in addition to this, there are a number of complexities facing scope 3 reporting. We might have issues with data collection and data quality. So do we have availability of the data? Do we have transparency? Are there gaps in the data? There might be scope and boundary issues, complex supply chains and ambiguous boundaries to those elements of your supply chain. Now, if you've been in this industry for a while, you may have heard the joke about why scope 3 went to therapy, because it had boundary issues. I can't hear the audience, so I'm going to assume that there was resounding applause for that joke and not a lot of groans. Next challenge is standardization. There's a lack of harmonized standards, and the guidelines for the various categories and for industries are evolving, and that adds further confusion and complexity. Companies might have resource constraints around time, internal or external expertise, or cost. There might not be budget allocated. We have dynamic value chains. So there's frequent changes to components, to suppliers, to countries that we're working with, and so on. Supplier engagement. There are challenges with incentivizing suppliers to provide data. There also might be cultural and regional differences. There might be mistrust. And this all makes it difficult to get accurate and timely data. There's regulatory and stakeholder pressure, compliance risks, investors, consumers all have an interest, and they all might have an interest in different types of data. So the complexity of providing multiple outputs to multiple audiences is a challenge. Integration with broader sustainability goals. So there's a need to align strategically with the company's goals around sustainability. There are challenges around technology integration and so on. Now, we're going to shift and focus on particularly category 1 within scope 3. This is purchased goods and services. Purchased goods and services often represents 35 to 40% of overall scope 3, particularly for manufacturing companies. So this makes it one of the most impactful areas for us to address. In addition to it representing such a large portion of our scope 3 emissions, most companies already understand their purchasing data. This lives in your ERP system. It lives in your PLM system. The data is generally available. So existing purchase data can be leveraged. And the analysis is simpler than it is in some of the other categories that can be quite complex. Decisions on products and suppliers can impact your emissions. So you have the influence, you have the ability to leverage your purchasing power to have an influence on these emissions. So not only are they easy to calculate, but you can easily have an impact. For example, you can make decisions on which products to buy, which vendors to partner with, and how to prioritize low emission suppliers over those that have higher emissions. This also makes category 1 an excellent starting point for meaningful reductions. But unfortunately, most companies are using a spend-based approach. Now, this is using economic input-output LCA data typically to apply an emission factor to your purchases based on financial data. So these are industry average emission factors that are being used, which makes it quite quick and scalable, but at the cost of being simplistic and imprecise. For example, a spend-based approach assumes that the supplier of a similar product will have the same embodied emissions in that product. So if you're buying 2 widgets from 2 different suppliers, this approach assumes that they're exactly the same in terms of emissions. And that's not actually true in practice. We know that different suppliers have different energy sources just based on where they are located or which purchasing decisions they choose to make for their energy. They might also have different levels of production efficiency, and this can lead to vastly different emissions for the same component, but spend-based treats them as identical. So not only does this limit the actionable insights that we can gain from this data, but it makes it hard to identify which suppliers we should engage with. So spend-based methods are a great starting point to get an understanding, to get a heat map of where your emissions might be in terms of overall, but they're not the solution. They fall short when it comes to driving meaningful reductions. So to achieve a real impact, companies need detailed activity-based data so that we can find those emission hotspots, so we can identify which suppliers are succeeding and which ones are falling short. Direct supplier engagement is key to identifying opportunities for reduction and achieving measurable progress. So at this point, I'd like to hand it over to Fabian to continue and get more into the how-to. Fabian?
Wonderful. So I hope you all hear me. I was just kicked out twice before because my computer crashed. So I hope everyone can see and hear me properly. What I like to look into with you is a bit more on how we are going to become more accurate with our Scope 3 reporting. And actually not how we only can become more accurate, but we also ask the question, what does actually make sense for you to do on moving forward with your Scope 3 reporting? And let's frankly say it, with the entire approach of not only solving Scope 3 reporting, but also how to address questions of LCA, maybe EPDs or eco-design as a total when looking into more what is the data that we are affected with. So while looking at the picture, we usually see that there is by increasing granularity, we have an additional amount of resources that we are required or that are required to complete the picture. Now, we have the usual common starting point, which is a spend-based Scope 3 reporting, which allows basically on a dollar-based purchasing amount using an average factor to predict or to estimate roughly an estimation of my environmental impact that I have on my Scope 3.1. There, I'm moving more into average data methods. It's a bit more granular, but it requires also more resources. This is things like I've modeled my top 10 contributing products in a more specific and granular way, so I get a bit of more insight from what my identifications on spend-based approaches was. That also is approaches where I predict and complete basically my spend-based or my transaction sheet with LCA data to have a more detailed picture all across my transactions into my Scope 3.1. And this may migrate also into supplier-specific primary data collection, where you request data from each of your single supplier. Now, why I'm usually saying there's a wider variety of options, because there's many ideas in there. Lately, there's the idea of taking GHG reports, Scope 1 to 3 reports, which are published, and allocate them down to a single product, which then can scale into your Scope 3.1. So basically taking corporate reporting to reflect a product carbon footprint, which is then used into 3.1. There are different approaches how to solve the problem along this line of granularity and along this line of becoming specific. The aim at the end, and we shall ask this for Scope 3 reporting, is to get an accurate result, which allows me to take actions, not only to report my values, but to take actions on how to improve my company's performance on Scope 3.1. And therefore, I need to go through a certain majority. In practical reality, just a second, I need to find the click. Yeah, here we go. In practical reality, that means the typical reporting of Scope 3 starts somewhere where this yellow bar is marked. This is a kind of an approach which is to a large degree spend-based. There are some activity-based factors in it. And then there is maybe also even already some primary data involved in this result. And now the question comes, what will I do next? Now, there's actually in this line of becoming more specific and more granular in my results, there is a question of what approaches do I have to choose from, and how can I approach this problem? So we marked here two approaches that can be seen, and this is from the left to the right. The recommended approach, I'd say. Well, you can also say an easier approach. Because what happens in here is that you first go in, do an assessment on a spend-based method, identify where are my hotspots, have some activity data, get a bit more of a granular picture. Now I'm going in and start to step by step, iteratively improve my results with an activity-based data. I can roll it out through AI-based approaches into my entire supply chain, get a deeper insight, but I'm enabled to identify the hotspots where I really need to spend the effort to collect supplier-specific data and ask my supplier to contribute with their knowledge and their data in my company's performance measurement. Now, why is the approach the other way around more challenging? Not considering any analysis of hotspots, not considering any activity data, which gives me indications of importance. Basically just means I asked my suppliers for information that they may not have in-house. Every company faces the challenge of data availability. Who can calculate for all of their products an appropriate product carbon footprint that can be submitted and according to all that variability of standards which are out there? Even if you're not asking for a product carbon footprint, then you're asking, hey, can you tell me your material data and your manufacturing energy so I can calculate it? And the supplier would say, but I don't have that data. Do you have that data? Can you somehow help me? So what do you do to help a supplier who needs to provide data? You will go out, you will prepare a certain predictive model and say, we assume this is your product. Can you confirm it or not? So in the end of the day, a fallback from any type of data collection where no one can give an answer today, what's the best way of collecting data? Because that will be for every supplier different, because everyone is at a different stage of data in this maturity curve. We'll fall back in, we give you an idea how you're performing and you confirm it to us, but we have already a good understanding where your performance sits, and we have a certain performance how we as a company can assess ourselves in our performances. What that leads to is, in the end of the day, the power of activity-based modeling. Data, which is not anymore spend-based but activity-based, is from a first approach very easy to understand. While on a spend-based approach, I assess every scenario very simple. Spend less money and you will have a better impact. That is entire nonsense. And I think that conclusion makes no sense. What we really would like to get to is, I would like to enable my engineering force to make technical decisions, be smarter, think better about what you purchase, what you produce, and their knowledge helps a company to get better. So basically a steered and controlled technical development against forecasted technical scenarios, while still being in the potential ability to run rough scenarios with potential improvements and simple energy scenarios and whatsoever. We have obviously a much higher granularity in decision making that can be reached. This can be done for procurement. This is for engineering, not only on scope 3, also in designs, in choices of suppliers, by getting to simple benchmarks and conformances between suppliers, maybe simple on regionalization, maybe of simple understood impacts by material composition of products, and so forth. And last but not least, we have experienced in the last 2 years, very often that customers come to us and say, hey, it's nice, we do a spend-based approach for scope 3.1, but our auditor tells us we can do this only so long, particularly because you're reporting LCAs publicly as well, and you're submitting them, and you're using 2 entire data sources for them. So we do not even know where your double counting and miscountings and overestimations and underestimations in your model sits, because you have no more harmonized data source. So what practically in a scope 3 belongs to is not only the thought, how do I solve scope 3, but it's the question, how do I solve data on a long run? And how do I solve the data challenge of having data for me to calculate and estimate supplier data available? And how do I collect supplier data controlled and very steered and targeted with relevant suppliers to improve my picture over time? I quickly like to give the example. We had this nice statement from Microsoft lately with working with us. They came from, inside of 3 years, they came from 20% of primary data in their systems up to 70% primary data. They basically spent the effort and increased or using AI predictions into their supply chain data, and then engage with their suppliers to improve this data further to reach a high level of coverage of primary data and to be able to report accurately. Slide. So it's basically a question is, where do you start and where do you move forward? You begin with a very mixed data situation, to summarize this. The spend-based data, AI classified data, Basically, you use the AI to just classify really your transaction data so that you can make a spend-based data. You uncover certain hotspots in your supply chain, and then you start improving. You add into it systematic results or AI, results through systematic AI predictions. You improve through targeted primary data collection. Okay? This is really the steps which fit with it. Now, it's also a question then, once I've started with this, how do I cycle it out, right? Wait a second, it's always the wrong button here that I'm pressing. Sorry for that. How to cycle out of spend-based data and basically fill the gaps. And that's what we see here. In an initial setup, the majority of the CO2 emissions are driven based on the spend-based approach, and there is some supplier gathered data in it. Adding basically AI predictions into this allows you to get very detailed and precise LCA results, right? Adapted to basically from generic data to the best possible knowledge of a tool and of a trained tool to your supplier's condition. And you remove already the impact of spend-based emissions in your setup. So you get more granular. And then it's a matter of time to iteratively improve the amount of AI data and supplier provided data until the spend-based data is entirely removed. What does that mean? And why do I do that? I basically migrate risk. Migrate risk to have two different results that I report that in the future won't be correct because I have to correct myself. Spend-based is shooting with a cannon on a sparrow. My result is as precise. So what do? I get data in which is precise, which allows me to have a confidence statement on my own performance and on my confidence statement on my actions. It's basically an outwards focusing reputation, which is there. Another part is sorry. Another part is you're building a baseline for the engagement with your supplier. Engaging with your supplier and working on initiatives together means also you need a benchmark which allows you to compare your supplier to. A result which is just going to be number. My result for that component is 3. Don't mean much as long as you don't understand in which ballpark reference products play and what the meaning of them is. Good. Now, the bigger question, and I think that's where most people start to get more interested about, is that the data that you need and where can you find it? In the end of the day, there is not that one uniform answer for each and every organization out there. Each and every organization that I have worked so far with, and just with Makersite, we have implemented, or I have basically implemented with my team more than 60 large-scale customers before that I have worked on. I don't know how many named large enterprises worldwide. Basically see a very inhomogeneous system, but you see something is being repetitive. You see that there's transactional data which builds the foundation, right? It's the amount purchased and basically just the cost. You see there's information in bill of materials and there's information in bill of processes, depends in which environment you're moving, which you find in ERP and PLM systems, what you find in them. You may find your own assembly structure, but you often find also information about materials, about weights, even about manufacturing processes, about alternative suppliers that you might be using that refer back to site data. Even site data means also your supplier's site data, right? Because in your procurement systems, you often have an understanding where does your supplier produce, in which region can data be regionalized on it, right? Just to make a quick cut, because to make that for everyone clear, the leaf information, so the last component of the bill of material of your assembly structure is practically the part which you purchase from your supplier. That's the same on a BOM as it is in your scope 3. It's the overlapping information. There's material master data and engineering standards which define themselves through ERP, PLM system, giving you additional information, materials, weights, manufacturing processes, standards that are allowed in your organization and not. There's FMD data for material declarations, which is sitting in ERP system, EHSQ systems, or in dedicated specialist system for compliance, for example, that have very clear information about material composition, about weights of parts that can be used for your purposes. Lately, we had this beautiful situation of CBAM coming in. Not sure if this is beautiful for everyone because it's a rather big challenge that the EU has given to organizations. But CBAM basically leads to a fact that every material regulated under CBOM needs to have a clear specification of the material, so you understand what it is, because if not, you cannot tax this, which you're obliged to, and you have to understand what's the weight of your materials and your components. Accordingly, you get a big piece of data to fill into your scope 3 information, because core is material, is weight, and component composition in the end of the day. Then there is obviously also customer data, right, which you may have already in your system, which procurement has collected. It's stored in the ERP tool, or it's directly maybe in a CRM tool. It may be also in data collection tools, which you have in-house, where you still have information that you have received from customers in the end. But most important, I think, on considering all the data that you may have in your own organization is that you tier the silos between down. And you can only tier silos between data down if you allow systems to integrate in the multitude of systems which you have in-house and connect them with the right data to give you the result. Practically, what this says, the input data in your organization comes from multiple systems. It may be your ERP tool, it may be your compliance tool, it may be the PLM, the PDM, the PIM. There's tons of tools which an organization has, and all these tools contain a little piece of information, and that looks for company A and organization A slightly different than for organization B, and most often, let's face it, in many business units as well. Business unit A often has a different ERP system than business unit B. It's nothing uncommon or unnormal. The question which is asked there, is this possible to take the data in an organization, to connect it with each other, tear down the silo of information, so weight information sitting in an FMD, so in a compliance data sheet, can that be integrated into your bill of material? And can that information contextually correctly be connected with supply chain data that you can consecutively improve by supplier engagement to more primary data coverage in your organization to reach the most precise result for your LCA and your scope 3 reporting? And when we remember back a few slides, just hopped a few slides, that's exactly what you see here. How can I smartly work with the data that I have in my organization? How can I take the silo away? And how can I integrate the data and over time improve them to receive the most coverage of the most precise data for the relevant, that's important, for the relevant materials and products or components within my organization. So how does that look? There's a little bit of an overlap, and it's also a question of which data is good for your results, right? So it's not that all data which is out there can be used, and then when your data is only half complete, any AI will come out and will do magic and will just say, hey, and now your data is amazing. The question is always, how big is the data coverage that you got, and what are the parameters that are covered? And what's the journey that I need to take and the approach that I need to take to cover it? What we try to visualize here is a bit of a picture that your bill of material that you see on a live is on the left side is functioning like a pyramid, right? So you produce one product through multiple assemblies, and at one point in time, you stop at your bill of material and you purchase a material or component from your supplier. These are the same material and components which you find again in your scope 3.1. It's just scope 3.1, a sum of all of these supplier components and materials that you purchased multiplied with the amount in the end of the day. What do I look for? For a good result, I look for good coverage of weight. Actually, the more weight that's covered, the better your result most likely will be. Another part is, or AI can go in and predict materials to that, right? To fill this. Even if you don't know your material, yeah, there is a possibility to fill gaps on materials, actually quite well to fill materials. And when you have a weight and you have a predicted material, you made already a big step. But without the weight, there's a challenge. Weight predictions are at the technical point hard to do today and are a custom case. Generally, there's the rule, if you have a bill of material from your supplier, or even if you haven't gotten it from your supplier, but you have to purchase the department that built a teardown BOM, for example, you can get your results a bit more precise. BOM can result, or the BOM from your engineering, you make a drawing in your CAD files, you have an understanding how something is composed, and you have an idea about your materials. This is a very good coverage and a very good source of data, can provide a much higher quality in your information. A BOM can also be a simple full material declaration that you use for compliance purposes, right, for these calculations. Last but not least, supplier location plays a very important role. The more supplier location and the more regular regional precision you get in your data, which energy grid has been used for the manufacturing. I live in Norway. If we produce here, we have rather the use of water power. Our impact will be lower, as if I produce in comparison, let it be Germany, where I'm from. They have, just based on the grid mix that is in place, a higher impact, as a simple example, right? It makes a significant discrepancy. So summing this a little bit up, what this can end up in is some real life stories. Here we have taken the case of a precision tool manufacturer. We didn't really want to name the name. On here, you'll find a few of them on our webpage. This is one reference case, which had a challenge, which you could just see out of this description that I've just provided you. There are issues which they have to basically integrate data from multiple ERP systems and PLM systems in their organization. And they had missing data, basically. And they had basically inconsistencies in their product design, cost analysis process because of this. So we basically built the solution for them. And we practically implemented, first of it, the robust data governance framework, meaning which data is used in which context, who has ownership to quality assure, check data, and system supported quality check and maintenance of data to reach basically your final result. But at the same time, integrated the tools into one single platform to harmonize all the data, combine the data from different sources to make most out of it. Yeah. Again, coming to the point, single data or siloed data in single places in an organization basically hide what you have in your organization and takes a lot of value. And combining it into one solution allowed exactly this to meet basically the business requirements in the end of the day. The customer got from us the ability to basically meet their reduction targets and had a direct integration between eco design and scope 3. Means if you can do eco design and scope 3, you basically have directly that. The engineering things, how to make a better product, and the benefit you will see on your scope 3 performances, but obviously also on your products by bringing the parameters together. Sorry, I always press the wrong button here. A second case is a wind turbine manufacturer, which had a slightly different challenge, I would say. Basically, investors and customers basically required full scope 3 carbon accounting from them, providing basically also information for EU taxonomy. And they faced the challenge that they basically had data scattered across multiple systems, covering more than 12 million components, meaning not even materials, but components, though. And practically leading to the pure fact that the current reporting in place, which had really the current reporting resolution in place just was not managing or did not manage and provide the insight into the reductions that they needed, or simply the transparency of information that they needed. What's the resulting solution? Makersite basically integrated more than 15 systems with each other, basically using our databases and using our algorithm and AI model, I would say, to basically achieve literally a fully transparent and supplier-specific supply chain for every single dollar spent within that entire organization. We provided them obviously deep insights into the data for impact analysis of suppliers, material, or technology changes. This is practically the technical forecast system which you're looking into, and then automated recommendations to support actually a cost-benefit analysis for the products. In the end of the day, this sums up to the ability to meet reduction targets, and integrate eco design into their and scope 3 into one and the same technical platform, reporting and analysis tools. So the last slide that I've really provided for you, and then we are coming soon to the Q&A session, is that falling behind and not keeping up with scope 3 reporting has actual consequences. there's basically different factors, right, which we had been discussing that lead manufacturers to lack. It's basically at the moment a heavy reliance on manual work by experts. This basically is a cure blocker for scalability. Why is this so? There's this beautiful statistic. One sustainability engineer, that's us here on the call, each and every of you, is basically in the need to answer sustainability questions to 3,000 engineers. As a no-brainer that don't work. So there needs to be basically a tool support to make sure that sustainability teams don't spend, or sustainability experts are not spending manual work, but helping and involving business to come to the results. It's a question, basically, in the end of the day, and that's the biggest factor of causing it. It's a matter of data availability, quality of data, ability to process non-perfect data, or non-perfect or unreliable data, and at the same time, the use of systems today for Scope 3.1 reporting or eco-design, which are simply not made to produce such a mass of information as an operational system. That's really the core to it. What's the risk with it is simply a lack of accurate and precise data for providing eco-design, producing better products, gives basically competitors an advantage edge in your competitive situation. It's a matter of reputation, of presentation outwards, how you appear as an organization, as just a few points coming into mind. Sales is obviously also a driver who is often more requested, right? Not maybe to provide Scope 3.1 data, but provide EPD, LCR, or PCF data information to in tenders, right? If this data needs to be available, solving Scope 3.1 data solves LCA. There's no question around it. It's the same methodology, or it's the same source of information to address two slightly different problems. Product managers are put under pressure, right, from sales, from procurement, from board levels, and more sustainable design products are required. How shall they do that if they don't have the data and the tools by hand and the informed decisions that sustainability experts such as us can provide to them? That was my last slide. Pablo, you like to say 1-2 words for the additional resources?
Sure, we do have a couple additional resources that we'd encourage you to look at. One is Oliver Hurry's Scope 3 peer group. They host meetings, workshops, and summits centered around the challenges of Scope 3 emissions. We'd also like to point you to the World Business Council on Sustainable Development's PACT program, that's Partnership for Transparency, which provides resources to organizations that are trying to decarbonize. Finally, the WBCSD also has Climate Drive, which is a membership-based collaboration to support supply chain decarbonization efforts with a net zero guidebook and the Climate Action Library. And with that, we would like to open it up to Q&A. We're just getting the questions together here. So the first question is, do you find AI to be an effective approach to develop proxy LCAs? Fabian.
Yeah, I mean, this is no question. It's also it's not everything on proxy LCAs. It's a matter of AI purely. So I think it's rather this is not the first question. It's the first question on the button, Antonio. You are right. It's the last question. It's the last question which comes first. Sorry for that. We'll go the other way around for a second. It's a good one. So first of it, it's not only a matter of creating an LCR randomly and by chance by using AI, right? So it's not like you say, hey, please give me a result for, I don't know, my gear or for my stator or whatever, and magically there's a result appearing by the AI. What is there is rather the question. I have data that comes from multiple information systems. This can be a generic data, that can be your in-house, that can be your supplier data, which allows you to tell an AI, hey, there is basically my gearbox or my stator already known. We have been working with this. It's contextually different used in this context. We may have a similar LCA model. So it's an adaptation of that model. Or it's a completion of the model saying, I take the data, I understand my supplier sits in Norway, again, where I live, and I'll adapt that data into that regional context by giving an assumption of material and energy compositions. Because it's very effective to basically tell AI how to use manufacturing process in the context of different material components of any way. Yeah, there's a very big use of AI, and it becomes very precise. So I think the question of precision is the biggest one, right? Let's say it this way. And it hangs a little bit obviously on the specificality of your data. So how precise is the data that initially can be worked with? But generally, and it's generally the precisions of AI get 80-90% upwards in taking data and predicting models into this for LCA, which I think is a very good achievement on it. I will not say for every materiality group and so forth, but yeah, it's very well achievable.
And as Antonio pointed out, that was not the first question that was asked, but I am being fed the questions in a certain order, and we will try to get to all the questions, so rest assured. Related to that first question, how can the accuracy of AI predictions be assessed?
Accuracy of AI predictions can be assessed. The first of it, any AI prediction model that works out there, and that should usually have a kind of a confidence and precision score, right? So you get a confidence, you get a precision, so you have an idea which quality you can achieve inside of certain predictions. That's number one. Typically, there are cutoffs made. You will never use predictions under a certain precision, because the likelihood of producing nonsense is getting much too high. Sorry for my wording, but that's true. It's literally nonsense when the precision don't perfectly map. So you have to make that cutoff. The second of it, this begins with very simple logical steps, right? So there are simple logical things. If you have a bit of experience in LCA, the easiest one is usually, if I predict a gearbox that has 20 kilo and has an impact of 80, and I predict of 80 kilograms CO2 equivalent, and I predict one with 1 kilo, and it is also 80 kilograms CO2 equivalent, one or the other must be wrong, right? And the easiest way to figure this out is to rescale, for example, data to 1 kilo. So you scale your impact on 1 kilo, and you will identify outliers and make sense check on your outliers. But then it goes further. The question is not always, is this really an outlier that, or the biggest question is really, is this an outlier I need to pay attention to? Because in the end of the day, you have a prediction and you can have wrong predictions, but if they're insignificant to your final results, so they're predicting, I don't know, in the 0 point something percentage of your masses, it doesn't matter. But if you predict on a high impact component, for example, it matters. So there is a little bit of a question. Not only what's the technical tools to it, there's also a little bit what our brain can fulfill, and it's also a little bit where, in which context data is then used within a model. I hope that answers your question. So
thank you.
It's difficult.
We've got one more AI-related question here. How do you envision the transition from industry average data to AI data and supplier data?
That question is, I'm not quite sure what you're looking for. So I have to think for a second. So what you mean, how I basically get industry average data out of the process? So practically, can you be a bit more precise? I'm super sorry. I think I will just talk nonsense again if I get a bit more precise question. Sorry, that gives me a chance.
Yeah, we'll see if we can get some more detail on that question. And the next question is, supplier-specific data also needs to be standardized. Otherwise, you can't compare apples to apples. WBCSD, TFS, and Catena X are working on such standards. Is Makersite a WBCSD packed conformance solution?
I wouldn't worry about if we are compliant to the standard. The question is, if you try to collect data for these standards with different methodological approaches, how does your supplier get the data to report into that standard? The challenge which you face in data collection is not that you have a standard not defined and that systems can't follow the standard. The question is, how does your supplier from whom you collect the data get the information that they need to produce these LCAs that they may need to respond to not only one of their customers, but maybe a few hundred, right? For a few hundred products or a few thousand products. That's the question which you ask. You may give out with the standard, and that's all what they answer. Please follow this approach, how to calculate data. But then, how do they do that? The big question that you need to ask to everyone, be it from the standards, what are the tools that data enables them to answer this, and how shall they make this happen? It's not only a tool question, how shall they get the data for this in a reasonable effort? And I think that's rather the question to answer. If we can get to a point, which I try to explain today, that allows us to get sustainability data operational, that's what I've been working on my entire life, really, how to operationalize sustainable data. It's not anymore a question of the standard because you get this data operational and you have it available. But right now, the data foundation to make it operational is not there. It needs to be worked on and improved so that you can report it to the standard.
Great, thank you. Here's a good one. Can you offer some distinctions between the role of PLM systems, which many interpret to be product lifecycle management systems, and the procurement systems, for example, Coupa, Ariba, GEP, etc., in the process of Scope 3 data collection?
In the process of Scope 3, so I have not really seen. I would need to think about the question. The challenge with it is that practically Scope 3 is in the first instance a transactional item, and the procurement team effort very often, if I'm making it simple. So it goes very often in the direction of procurement team or data collection tool, which feeds the information then back into the ERP tool. The PLM tool is often just a carrier for secondary information, right? So you have a lot of information around your materials, PLM, PDM, in your rather around information about materials and components in the two tools or in these tools. That means they are basically the in-between step. When I do not collect the data from my primary data source, then I basically use the data from the PLM, PDM tool together with the ERP tool information to make basically the activity-based approach in the middle, which is not primary data, when you remember my picture. But I would need to think about the question a bit more in detail, give you a little bit more extensive response.
Let's see. Can you help us understand how spend-based methods with AI could help meet the CSRD double materiality standard?
I would need to ask my colleagues straight out. Not my field to answer, but we'll note it. We'll send you a response.
Is there guidance on the overlap problem of inbound scope 3.x? For example, freight emissions to deliver my inbound 3.1 materials. Do specific standards normalize whose data should address these affiliated scope 3.x so that it is not reported via double dipping?
I'm super sorry. Where do you have an overlap problem between those?
So I think I can address that. So as I mentioned, there's a certain amount of double counting that occurs in scope 3. So for example, when you take a flight, that is included in your scope 3 business travel emissions, but the airline is also accounting for the emissions of fuel combustion within their owned or leased assets. So that would be their scope 1. In addition, the fuel supplier will be including the emissions of combusting their fuel in terms of their downstream scope 3 emissions. So like I said, scope 3 includes quite a bit of double counting, and that is by design. We're looking at taking responsibility for emissions. So it's not necessarily emissions that we directly emit or even have influence over, but we are using scope 3 as a framework for taking responsibility.
Then there's Adriana. Are such AI-based calculations allowed if you are calculating your emissions to GHG protocol? Yes, they are. What about SPI? Yes, they are. This has been seen that this can be audited and get verified. Yes, this is not the question.
What scale of firm is the smallest Makersite currently serves, and whom you hope to reach? Or let's see, or are you focused on enterprise scale mostly?
I'd say medium and large size manufacturers. This is the core target. I wouldn't even know out of my head who is the smallest, but it will be all in the medium sized companies. It's unlikely that we have an SME in our bandwidth, because what we are addressing is a rather big question around data automation and system automation. So there needs to be there is a certain maturity which you reach if you are a medium or large scale manufacturer.
Yeah, and I would add it's mostly around the complexity. So it's either large companies with thousands of products or companies with incredibly complex products like wind turbines or generators with thousands of parts each. All right. I think we only have about a minute left. Let's see if there's one last. No, I think that's all the questions. So I'd like to take this last minute to invite you to our next masterclass, Trusting LCAs at Scale. This will take place in February on the 19th and will be led by our colleagues, Alexander and Sophie. I hope you will join us, and thank you for joining us today.
Thanks, everyone.